Well, hello there. I'm Mr. Vona, and we are graphing circles. All right, this is part two of a two-part series of videos that I'm doing on graphing circles. And so here's an example. We want to find the center and the radius, and we're going to graph the circle. And all we're given is this equation. Okay, and I want you to notice something. Is this an equation? How can you tell if this is for circles and not for parabolas? Well, you'll notice that we have two variables in here, right? We have x's and y's. So we know that this is not a parabola. This is going to be a circle or maybe even an ellipse, but let's find out. All right, so the first thing we want to do, because we want to get this into that familiar form. Remember that familiar form of x minus h squared plus y minus k squared equals r squared. Remember, that was the equation for any circle that is not centered at the origin. Okay, and of course, if h and k are 0, then it's just going to be at the origin. Okay, so how are we going to get this equation into this form? Well, first thing we need to do is, I don't know if you noticed, but this is the square of a binomial. In other words, x minus h squared is the same thing as x minus h times x minus h. Right? And to get the square of a binomial, that's called basically a perfect square. In order to get a square of a binomial, we have to complete the square, which we've learned in a previous video. Okay, so we're going to end up completing the square in this one. Okay, but in order to do that, we really need to get our x's and our y's together. All right, so let's go ahead and do that. All right, so we have x squared right here. I'm going to just start with my x's because those always come first anyways, right? So I have x squared. And then I'm going to skip over and I got an 8x right here. Okay, so I'm just going to kind of put these guys together. Okay, because I need all my x's together. Now I need all my y's together. So I got plus y squared. By the way, if it was just looked like that, x squared plus y squared, that is a circle right at the origin, right? But then we got these other guys in here. We got this minus 2y. So I got my x's together and my y's together. Now take a look at this. I got that 15 right there. Okay, that's a constant. These other pieces right here, these other terms, they're not constants. They have variables in them. And if you'll notice that on my final equation for my circle, my constant is going to be my radius. And my radius is on the other side of the equal sign. So eventually I'm going to need to move this 15 over to the right side of the equation. And I might as well do it now. All right, so the way I do that is I just simply subtract 15 to both sides. Okay, and that negative 15 is going to end up being a radius. I hope it turns out to be a positive. All right, so let's take a look. That's going to be negative 15. Okay, just move this 15 over by subtracting 15 to both sides. All right, so what I'm going to do is I'm going to, just for visual sake, I'm going to kind of parentheses those, put parentheses around those two terms. Okay, so now I'm going to need to complete the square for my x's and my y's. All right, so in order to do that, I get x squared plus 8x, and I'm going to need some c term right there, right, for this to be a complete square. I'm going to add, okay, y squared minus 2y plus, and I'm going to have to complete the square on this one as well, equals negative 15. All right. So I need to figure out what this c value is going to be for my x's and my y's. All right, well, how do I do that? Well, I don't know if you remember how to complete the square, but the little formula that helps us is this one right here. Let me do that in a different color. So I have c equals b over 2 squared. Remember that? That's my little form. That's what c needs to be for this to be a perfect square trinomial. Excuse me. It's springtime in Fresno, huh? All right, so I have a trinomial here. What does this c need to be? Well, c needs to be b over 2 squared. Excuse me. Whew. All right. So c equals b over 2. What's b? b is 8. All right. So c equals b. b is 8 in this case. Over 2 squared. All right. So 8 over 2 is 4. And 4 squared is 16. I must be allergic to completing the square. So x squared plus 8x plus c needs to be 16 for this to be a perfect square trinomial. By the way, you'll notice that 16 is a perfect square, isn't it? Square root of 16 is 4. All right, so how about the y's? So I have y squared minus 2y plus c. Well, what does c need to be for my y terms? Well, in this case, b is negative 2. So I'm going to put a negative 2 there. So what's negative 2 divided by negative 2? Excuse me, what's negative 2 divided by positive 2? It's negative 1. And negative 1 squared is positive 1. The cool thing about when you square a number, you're always going to come up with a positive number. All right, so that's going to be plus 1. And you know what? Let's put this in a special color over here too. Because I'm just adding these two numbers to my equation. And of course that's going to equal negative 15. Now because I added 16 to the left, I'm going to need to add 16 to the right. And because I also added 1 to the left, so I have to add that 1. So basically I add a total of 17 to the left, so I have to add a total of 17 to the right. All right, so let's go ahead and factor this trinomial right here. So you'll notice that this AC goes here in B, right? This is the AC method we learned. So A times C, well, A is 1, C is 16. So that means that AC is 16 and B is 8. Okay, can you think of two numbers that multiply to give me 16 and add to give me 8? You got it? All right, well, this is what I get. 4 and 4. All right, 4 times 4 is 16, and 4 plus 4 is 8. Okay, so I would factor this then as, so 4 and 4, those are my two numbers, right? 4 and 4. I would factor this as x plus 4, x plus 4. And we learned that way back in Unit 4. All right, plus. All right, let's look at these guys. Let's go ahead and factor these guys. So AC is just 1 times 1, which is 1, and B is negative 2. All right, so what two numbers are going to multiply to give me 1 and add to give me negative 2? Well, there's only one way to get 1 by multiplying, and that is 1 times 1. 1 plus 1 is 2, not negative 2. But there's two ways to get a positive number by multiplying. You can multiply two positives or you can multiply two negatives. So I'm going to try multiplying two negatives. So negative 1 times negative 1 is positive 1. Negative 1 plus a negative 1 is negative 2. Bingo. So there are my two magic numbers. So I'm going to go ahead and put that into my factored form. So I get y minus 1 and y minus 1. You see how that's a perfect square? Because if this was area, length times width, my length and my width are identical. Same over here. My length and my width are identical. Therefore, it's a square. All right, so I get minus 15 plus 16 plus 1. All right, well, 16 plus 1 is 17, and 17 minus 15 is 2. So I'm going to get a positive 2 over here. All right. Now we're starting to get someplace. Now I have this right here, x plus 4 times x plus 4. I can write that in exponential form. I can write that as x plus 4 to the second power, right? Is that starting to look familiar? Right? Plus, and I got y minus 1 times y minus 1. Well, that's just y minus 1 squared. All right, and that's going to be equal to, all right, so what number squared is 2? Oh, what number squared is 2? Well, I can't do 2 squared because 2 squared is not 2, is it? 2 squared is 4. If I could just think of something that would cancel out that 2 so that I would just be left with 2, right? What cancels out a square? You got it. A square root, right? So the square root of 2 squared is just 2. Boom, right there. So this means that my radius is the square root of 2. Okay, in fact, maybe it would help if I wrote it like this. All right, my radius is just the square root of 2. All right, so this tells me that my center is going to be located where? My center is going to be located at, well, what's my horizontal shift? Well, you would think it would be 4, right? But it's actually negative 4, right? This has got to be a negative 4. Just think the opposite. So my horizontal shift is negative 4, and my vertical shift is positive 1. Okay, so there's my center. And my radius. What's my radius? Well, what number is squared? What number is squared? Square root of 2. Square root of 2 is my radius. All right. So let's go ahead and see if we can graph this thing. All right, so my center is at negative 4 and 1. So let's see, I start at my origin, and I go negative 4, left, 1, 2, 3, 4, and I go up 1. So 1, 2, 3, 4, and up 1. All right, there's my center. My center is at negative 4, 1. And my radius is square root of 2. The square root of 2, if you were to do this find this on your calculator, the square root of 2 is approximately 1.414, something like that. Okay, how about we just call it 1.5? Because graphing, it's not going to be that accurate anyways. Right, so it's about 1.5. All right, so if I'm going to graph this from my center, I got to move in all directions. I got to move out 1.5. So there's 1, and there's a half. All right? There's 1, there's a half. There's 1, there's a half. There's 1, and there's a half. All right, and then I just connect my dots. It's not a very good circle because my lines are not, my grid lines are not really equal. So it's actually really an ellipse. Okay, so there's my circle. It has a center of -4, 1. It's got a radius of about 1.5, square root of 2. And there's my graph. So the way I had to do that, I had to, when I have it like this, I need to complete the square so I can get it in this form. Right? And then I can figure out my center, my radius, and I can graph it. All right? Try a few of these out. I mean, I know this is a little complicated at first. A little bit of practice, especially once you get good at completing the square. This is actually not too hard. All right? So good luck, and make sure you subscribe to my YouTube channel. That way you can get informed whenever I make new videos. All right? Until next time, may God bless you, my friends.